What's going on, mathletes? We are looking at our introduction here to exponential functions. All right, so as you copy this down, exponential functions, what we could think about it are functions that are either going to grow very fast or they're going to die off really fast. I know exponential, we're thinking growth, but we're going to take a look at some different scenarios today. But first I want to focus on those functions that are going to grow really fast. And this is one of them. So you have 2 raised to the x power. Alright, so what we're going to do before we talk too much about this is let's make a little chart here, a little table. Alright, we'll have some x values that we'll just choose, and then we'll have our outputs, our heights associated to each one of those x values. Alright, so let's get this down here. Alright, so we're going to pick some points to plot. So let's start with -3. Alright, so we're going to go ahead and we're going to plug in f of -3. Alright, in doing so, we get 2 raised to the -3rd power. And hopefully we remember from our rules of exponents that this negative exponent, right, is going to cause this base to go to the denominator. And now the 3 turns to +3. The -3 turns to +3. So we're left with 1/8. Alright, so when you get -3, when you plug in -3, our output is 1/8. Alright, so -3 and our output was 0.125. Alright, so let's go ahead and plug in -2. So we'll have f of -2. So let's go ahead and plug that in. Alright, and again, this negative is we're going to take the reciprocal of this space, and that -2 turns into a +2. So we got 1/2 squared, which is 1/4. So we get 0.25. Alright, so take a look as we're getting closer and closer to 0 as we're increasing our x value, right? We're increasing our x value. Notice our y value, f of x, is also increasing. So let's see what happens when you plug in -1. Alright, so we plug in -1 and you get 2 raised to the -1st power is 1/2, which we know is 0.5. Alright, cool. So we see these y values increasing here. We'll plug in the nicest number in the world, 0. Right, just like some of our bank accounts. So we get 2 raised to the power of 0. Anything raised to the power of 0, good, is just 1. Alright, for the rest of these we could do these in our head. So what do we get when we plug in 1? Excellent. If you heard the person right behind you, they said you get 2. And if you plug in 2, you get 2 squared, so we end up with, excellent, 4. And if we plug in 3, we get, right, we're going to plug in 3 into our exponent here, and we get 2 to the 3rd power, which is 2 times 2 times 2, which is 8. But on test day, we all know that becomes 6. Alright, so there is our little chart. So let's go ahead and graph this chart. Alright, so let's take a look at how this graph is going to look, and then we can make some generalizations based on this chart. Alright, so once we look at the graph, you're going to see you're going to get this exponential graph right here. So notice what I did. I just graphed the points 0, 1. So this was one of my points. Let me kind of point to them here so you kind of see what I'm talking about. So this is 0, 1. So I did the nice ones. We could do -1.5, right? If we graph that, -1.5, that's this height right here that I made the dot in white right there. All right. We could do 1, 2, right? 1, if we go over 1, up 2, we get this point right here. So let me make that dot right there for you. Right, and then let's go with the next point, 2, 4, right? We're going to go right 2 up 4, right? So notice if this would have been 2 and then yours right here, I would have gone over 2 and then up yours. But anyways, little math joke for you. So 2, 4, we go over 2, up 4. So that's right there. And then we have 3, 8. So we go right 3, up 8. So that's that point right there. So let me make that for you. Bam. So all we did is we just connect those dots. And this is going to grow exponentially. All right, so our exponential functions are going to have this general shape right there. And they're going to increase very rapidly, as you see. All right, so this is our generic exponential, shape that we're going to see. But this is going to be the shape when the base is greater than 1. And we'll get into all those good details here. But I just want to do an example of what does an exponential function look like. All right, so let's jot some things down here. All right, so I'll let you copy that down while we take a little quick commercial break. Remember, this video was brought to you by The Karate Kid 3, coming out this summer, July 15th. Look out for The Karate Kid Part 3. Alright, so now that we're all jazzed about that Karate Kid movie, let's move on. Okay, so let's look at a generic exponential function here. Okay, so we have f of x equals b to the x. And in this case, we're going to look at what happens when b is greater than 1, right? When our base is greater than 1. All right, so this is what we can expect. So we're always going to have this general function, right? So this is how it's going to look. So here's our x-axis. Here's our y-axis, just so we could do it quickly here. So some things to jot down. So our y-intercept, so notice I don't have a number per se that I'm going to plug in for b. So it's just b to the x. But what happens when, for our y-intercept here, we know our x value is 0. So what happens when you plug in 0 for our x value? Well, we know our b value is greater than 1, so any number greater than 1, anything raised to the power of 0, we know is good. That person in the back is just tearing it up, answering all these questions. Good. It's 1. So regardless of what number you choose for b, right, you're going to get the output, the height of 1. So this is the point 0, 1. So our y-intercept is always going to be 0, 1 when we have this basic exponential function right here. All right, and we kind of saw the generic shape here, that it's going to increase slowly, then bam, it's going to go fast. It's going to grow really fast, right? So this is going to be our generic shape. One thing that we're going to learn, right, if we zoom in here, we're going to see that this line here, right, this function, we're going to see this function right here is going to get really close to the x-axis but never touch it. So here I draw this blue dotted line because this is what we call our horizontal asymptote. So this is our asymptote. We're never going to reach 0. So this function, the height, which is f of x, never is going to reach 0. And again, I'm talking about this basic function right here. All right, once we add and subtract some numbers, we're going to see some things change. But this is, again, our generic function here. It's our most basic model. All right, so this is our base model. All right, what else do we notice? Well, let's talk about the domain. All right, let's look at our domain here. Another idea that I'm sure you're familiar with. All right, so our domain, we know we're talking about our x values, so we're looking from left to right. So this function, how far is it going to the left? Well, we could see it's going to go all the way down to negative infinity. and it's going to go to the right all the way to positive infinity. Perfect. So our domain is from negative infinity to positive infinity. So our domain is all real numbers. And then our range. Right? What's the lowest point to the highest point, right? So we saw that it was approaching, right? It was approaching what height? Excellent, 0. Is it ever going to touch 0? We said that right here, right? Never touches 0. So it's going to approach 0, so we got to open parentheses, and it's going to go all the way to positive infinity. So 0 to positive infinity. So there is our range. Excellent. All right, so let's look at some things. Let's make some changes. But this is our generic, we'll call it our base model, our most basic model right here of f of x equals b to the x, because we're going to make some changes. We're going to make some improvements to this base model right now. All right, so I'll let you copy that down. So I see there's a lot of worried faces. This might be a little confusing, but don't worry. I just want to remind you, if you have trouble in this section, you always have someone to call on. And wait, what's that in the corner? Oh yes, whenever you're in trouble, just call on Dr. Math, and he'll be there. Okay, so I was just told by my producers that was a little creepy, so my bad. All right, so let's move on to this next section here. All right, so let's change the game up a little bit. All right, so let's look at the following. F of x equals 2 to the x. Let's say we have plus 3. So in this situation, notice we're adding some constant out to the side. All right, so let's do a little sketch here real fast. All right, so what I always want to start with is, let's start with our base model. So let's start with, I don't want to call it, actually, let's see, let me get rid of this. Let me call the base model g of x. So we know what 2 to the x looks like, right? So 2 to the x is gonna look like this, and we know our y-intercept is the point 0, 1. Right, that's our base model. So my question to you is, what is this plus 3 going to do? All right, that's the big question. All right, because I'm going to be honest. Some of you looked at that plus 3, and this is the expression that I saw in a lot of your faces. Right? This was most of you right there. You're like, plus 3? What the hell is going on here? All right, so let me help you out, because it's actually not that bad. All right, so let's think of something real fast. Let's go ahead and plug in a number. All right, so let's go ahead and plug in 0, because we know before, when you plugged in 0, right over here in our base model, our output was 1. All right, so what happens now when our x is 0? So let's go ahead and plug in 0 into our function. All right, so let's do that. So we'll have 2 raised to the power of 0 plus 3. We said that anything raised to the power of 0 is 1, so we have 1 plus 3. So we get 4. So notice, before our height was 1, but now, excuse me, our height is 4. So what happened was our whole function is going to go, it was right here, it's going to move up 3 units. So that's what this plus 3 does, is it takes this graph, this function here, pretend it's like a wire, that's a solid wire. We're going to pick it up physically and move every single point up 3 units. So every single one of those y values is going to move up 3 units. So when I draw this now, right, it's going to have that same shape, but now all those points are going to go up 4 units. All right. So this plus 3 in our notes, make sure it's very clear that you understand that this plus 3, maybe that's not a good idea to put it there. Maybe up here somewhere, but I'll just write it. So this plus 3 shifts the graph, the function, up 3 units. All right, so that's what that plus 3 does. All right, so you could imagine, let's get a new example here real fast. If I asked you, describe what, let's copy this one down. Describe what this minus 3 does, right? So let me go ahead and highlight that. Let me choose a different color here. So what is this minus 3 going to do? Well, if this up here shifted 3 units up, well, we could guess, make an educated guess here that this minus 3, let me use a black here, this minus 3 is going to shift the function, I'll call it the graph now because everyone loves to use that word, down 3 units. All right, so let's go ahead and make sure we have that in our notes so we're able to tackle those questions.